relate an equation to a balanced scale. In an equation, the equal sign represents a balance between the left and right side of the equation. Let's visualize equality between two expressions by representing these expressions on a scale. In each diagram, think of 1 as 1 unit weight. If we have the same number of unit weights on both sides of the scale, then the scale is balanced. If we have a different number of weights on each side of the scale, then the scale is unbalanced. Now consider the equation y plus 3 equals 8. How can we represent on a scale that the expression y plus 3 is equal to 8? Well, on the right side of the scale we have 8 unit weights. On the left side we would have 3 unit weights as well as a bag labeled y. Recall that we use a bag to represent an unknown number of weights, and the variable y to represent the total number of unit weights in the bag. Since we are given that the quantities y plus 3 and 8 are equal, we show the scale as balanced. Looking at the scale, it hopefully makes sense that we can determine how many unit weights are in the bag y by determining how many unit weights balances the one bag. To do this, we will need to get the bag by itself, which we can do by removing unit weights. Notice that if we remove one weight from the left side, then the scale would fall out of balance. This is a good indication that we have done something incorrectly. If, on the other hand, we remove one unit weight from both sides of the scale, then the scale remains balanced because both sides have been changed in exactly the same way. We can repeat this action 2 more times, and in total, remove 3 unit weights from each side of the scale. Since we have removed the same weight from both sides, the scale remains balanced. From the scale, we can see that the bag of y unit weights balances with 5 unit weights. This tells us that the bag labeled y must contain 5 unit weights. Therefore, y equals 5 is the solution to the equation y plus 3 equals 8. So this is great. We have determined the solution to the equation. But is it possible for us to explain this process using algebra? On the scale, we removed 3 unit weights from each side. Numerically, we can subtract 3 from each side of the equation, and so y plus 3 equals 8 becomes y plus 3 subtract 3 equals 8 subtract 3. Recall that 3 and negative 3 are opposite integers, and so they have a sum of 0. As a result, this equation simplifies to y is equal to 8 subtract 3, or y equals 5. Now you may have noticed that the solution was y equals 5 at the very beginning just by looking at the equation. So the steps we are taking to solve this equation might seem like extra unnecessary work right now. But very soon we're going to be required to solve more complicated equations, and then these strategies are going to prove to be more helpful.